In this video, we're going to look at the four conic sections, which are a parabola, circle, ellipse, and hyperbola. And we call these graphs conic sections because they're the shapes you get if you were to take a cone and cut it in different angles. So the first important skill we'll need is to be able to identify what type of conic section we're looking at, just given an equation in general form like this. And so these are all general form, and you can see these equations all look incredibly similar. There's just a few differences in each one. One thing I like to do if I'm dealing with a new type of equation is just plug it into Desmos and see what the graph looks like. So while we pull up graphs of these, let's look at some of the differences in each of these equations. So the first one, the main characteristic about it is the fact that there's only one variable being squared. Like we have an x squared, but there's no y squared term. And you've actually seen this type of equation before. Let's actually just rearrange it a little bit. I'm going to solve this for y. Since there's just one y variable there, it'll be really easy to get it alone, whereas there's two x variables. But I could subtract an x squared over to the other side, subtract a 2x, and add a 12. And then if I just divided everything by 4, it would get a little messy here. I'm going to write this as negative 1/4 x squared minus 1/2 x plus 3. And this is just a parabola. The second example is a little bit different because we still have the x squared and 2x, but now we have a y squared and 4y. So we do have a y squared term now. And if you take a look at the graph, this one turns out to be a circle. In number 3, we have an x squared and a y squared term. And actually everything else is the same as the other equation we just looked at in number 2. But the difference here is we have 2y squared, so there's a different coefficient in front of one of the variables. So you can almost think of this as being a circle, except for it's being stretched one way or another, because this is kind of like a vertical or a horizontal stretch. And if you take a circle and stretch it one way, it'll become an ellipse. Number 4 is almost identical to this equation for number 3. Again, the only difference here is that we have a negative 2y squared. So we have both variables being squared, they have different coefficients, and they're being subtracted. And this graph is called a hyperbola. We've actually graphed these types of things before, these hyperbolas, back in the rationals unit, but those were always at some kind of angle, and these are always going to be like either horizontal or vertical. So now we have these four equations. They each represent a different type of conic section, and we looked at the different characteristics of each one, so how they're different from each other. But the problem is these are just like big long strings of numbers and variables, and they don't tell us much about the graph. So what we want to do is use completing the square to rewrite these things in standard form. And standard form helps us see like the center and the radius and different things about the actual graph. So like I said, this first one is a parabola, and this is going to be the easiest equation to work with, and we'll start here. So when you're completing the square, what you want to do is kind of reorganize it a lot of times so that the x squared and the x is together, and like the y squared and the y are together, but we don't have any y squareds here, so this is already pretty much set up for us. I'm just going to kind of isolate this, so I'm going to subtract 4y over to the other side, and I'm going to add 12 over. So that just moved them over to the right side. And now completing the square, like the whole point of this is to rewrite this in basically this form. We want some kind of factor being squared. And the process that you've probably learned for doing this is to just bring this down and write x, not x squared, just x, because the squared is out here now. And then you take half of this like b value, so half of that would be just plus 1. So the point is we're just trying to rewrite this in a different form. But here's the problem. If you take this and FOIL it back out, you would get x squared plus 2x plus 1 at the end, because you'd have to take 1 times 1. And that's not what we had up here. So what we're actually going to do is we're going to go back up here and fix it. We're just going to add 1. But that's weird. You can't just add 1 to a problem and call it good. You have to do the same thing to both sides. So I'll just add 1 over here. So I'm going to get rid of this because that was just kind of like checking what's going on. And then let's rewrite what we have on the right side now. So the left side is all good. And then over here I've got negative 4y. And then the plus 12 and plus 1 together, that would be plus 13. Now, since I know this is a parabola, and I can already see the structure in this a little bit, I'm going to just solve this for y, just get that alone. So I'll have x plus 1 in parentheses squared. I'm going to subtract that 13 over, and then I'd have to divide everything by negative 4, and that would give me y. So now I'll just rewrite this a little bit nicer looking. So instead of dividing by negative 4, I'm going to write that as negative 1/4, kind of like we had before. And then x plus 1 squared, and then these negatives would cancel, so plus 13 over 4. So you've already learned before that a parabola's equation in vertex form is y equals a times x minus h squared plus k. And this tells you the vertex. So like in this example, the h value is actually negative 1 because in this form it's being subtracted, but our equation is being added, so it's the opposite. So the vertex would be negative 1 comma 13 over 4. Now you can also have a parabola that goes sideways, so it would be opening to the left or to the right, and it's basically the same equation, but we do have to flip the variables. So since we switched the x and the y, we also have to switch the h and the k, which are the x and the y values for the vertex. So it makes sense that all of the x and the y's are just switching. So for this equation, the vertex would still be hk, it's just that the h and the k are in different spots in the equation. So let's try completing the square with number 2 now. Now, we don't have this thing organized as nicely because the x squared and y squared are together, so I'm just going to rewrite it so it's x squared plus 2x. I'll get all the x terms together, and then I'll write the y terms together, so y squared plus 4y. And you can see I left a space here, you'll see why in a second. And then let's just get rid of that negative 12. We'll just move that over to the other side. So remember, the point of completing the square is to be able to write something in like this factored form, or this squared form. So we would bring down the x, and then we just take half of the b value, so plus 1. But remember, just like in the last equation, if I were to FOIL that back out, we wouldn't just get x squared plus 2x, there would be that extra plus 1. So we have to go back and add that. Actually, I'll do that in a different color, so plus 1. And then we can't just do that to the left side, we got to do it to both sides, so plus 1 over there too. So now let's do the same thing for the y's. So write this as something squared, and just bring down the y and half of like this b value, so plus 2. But again, we have 2 squared here, which is 4, and we didn't have a plus 4 here, so we have to add a plus 4. And we got to do it to both sides. And everything over here was positive, so I'm just going to put a plus between these parentheses. And then plus 1 plus 4, that's 5, plus 12 would be 17. We saw before that this is a circle, and you may or may not have seen before that the equation for a circle is x minus h squared plus y minus k squared, and then the right-hand side is r squared. It's the radius of the circle squared. So the radius of this circle would actually be the square root of 17, right? Because 17 is r squared, so I'd have to take the square root to get the radius. And again, I see that the signs are different here between the equations. So the center of this circle is actually the opposite of these numbers. So it wouldn't be positive 1, the x value would be negative 1, comma, the y value would be negative 2. So when it was written in general form like this, I really didn't know anything about the circle. I just knew that it was a circle because I saw that both variables were being squared and they had the same coefficients. But now I can see that the center is at negative 1, negative 2, and the radius is a little bit more than the square root of 16, so that means it's a little bit more than 4. So it would be really easy for me to graph this quickly. So let's just move on to the next 2 examples, and we'll do the same thing. So I'm going to reorganize the terms so that x squared and 2x are together, and the 2y squared and 4y are together. And then just move the negative 12 over to the other side, so plus 12. So I can start exactly like I did before. I'm going to write this in parentheses here, so this would be x plus 1 squared. But then going back up here, I have to add a 1, because remember, if I squared this back out, I would have a plus 1 that I didn't originally have. So I'm going to add that back into the equation, but then I have to add it to the other side as well. But now, here's why this one's a little bit different. I've got this coefficient of a 2 in front of the y squared. And if I'm going to complete the square, I can't have that 2 there. So actually what I'm going to do is just factor the 2 out of both of these y terms. It's like a little mini factoring problem. So I'll pull that 2 out front, and I get y squared plus 2y. Alright, so this is what I'm going to work with. So I'm actually going to leave this big plus 2 here, and then I'm going to complete the square with this. So again, you just bring the y down, and then you take like half of this b value, so that would be like plus 1. But now let's think about what we just did. If I were to FOIL this back out, I would get a big 2 here, and then y squared plus 2y plus 1. 1 squared is just 1. But then I'd have to distribute this 2 in, so I'd have 2y squared plus 4y plus 2. And that almost matches what I originally had. I've got the 2y squared plus 4y, that's the same, but I have this extra plus 2. So I didn't accurately rewrite this. Like when I completed the square, I changed the problem a little bit. I added this plus 2. So we have to go back and add that plus 2. So then on the right side, we have 12 plus 1 is 13, plus 2 is 15. And there we go, we've completed the square. But in this form, we still don't know a whole lot about the ellipse. We do know the center, but we don't know much about like how wide or how tall it is. So actually what we're going to do is we're going to make this 1. So in order to make this a 1, I'll just divide everything by 15. I could divide the right side by 15 and divide everything on the left side by 15. So there's nothing much to do in the first term, we just rewrite it here. But this is going to be kind of weird. I'm actually going to change this 2 over 15 so that I don't have anything in the top. I want to just have y plus 1 squared up there. I don't want to have any other coefficient. So 2 over 15, if I divided the top and the bottom by 2, that would be the same as 1 over 7.5. And I would normally tell you guys it's not okay to have a decimal inside a fraction, but in this case we'll do that because this will actually tell us something about the ellipse. And then on the right side we just have 1. So the standard form would be x minus h squared and y minus k squared, just like it is for a circle. But in an ellipse, we have these fractions. So this is being divided by, we'll call this r1 squared, and this is being divided by, we'll call this r2 squared. There's a plus sign in the middle, and this always equals 1. We always want this to be 1. So like we already saw a couple times, these signs are different in the equations. So the center of this ellipse would be -1 comma -1. But now we have these two radii, and that's because an ellipse has different dimensions, right? Like it's wider or taller in one direction. So since this is the first radius being squared, the actual radius would be the square root of 15, and radius 2 would be the square root of 7.5. Now number 4 is very similar to number 3. The only difference is that we're subtracting here. So it's really tempting to think that we're going to get the same equation as down here. We just have to put a minus sign in the middle. But if you go through the work, you'll see that it is actually a little different. So again, I'll start the same. I'll write x squared plus 2x together, and then I'll put the minus 2y squared plus 4y together, and move the 12 over to the other side. And again, the goal is to get these factors squared, so I'll write that out, and then just fill in the blanks. So we'll take the x down here, and then half of the b value would be plus 1. Now just like in the last example, I've got this -2 in front of the y squared, and I got to get rid of that. So I'm just going to factor it out of both of these terms, just like a little mini factoring problem, and that would leave me with this. So now when I bring this down into the factored form, this would be like y minus 1, right, half of that b value. But now if I factored this back out, I would get y squared minus 2y plus 1. Oops, not squared. But there's that minus 2 in front, and if I distribute that in, I'd have a -2 that I didn't have up here. So I have to put a -2 in there. So we have a minus 2 from that, and actually I just remembered that we've got to put this plus 1 from the x's. So then we've got plus 1 minus 2, we've got to write that on the right side as well. So 12 plus 1 is 13, minus 2 would be 11, so this equals 11. And we can't forget to bring this -2 down. Alright, so now we have everything represented here. Just like before, I want to make this a 1 to put it in standard form. So I'll do that by dividing everything by 11. But just like before, I don't want to have this minus 2 in the top of this fraction, so I'll leave the y minus 1 where it was, squared. But then instead of having 11 on the bottom, I'm going to divide the top and the bottom by 2. We'll get rid of the 2 on top. And then on bottom I'd have 5.5. Over here this just equals 1. Now this is a hyperbola, so it doesn't really have a radius, but we can still find the center of it, which would be these points again. Now you can think of these numbers as kind of stretching the graph one way or the other, but like I said, since it's not an ellipse, it doesn't have a radius, so we'll just be identifying the center. So with everything we've just gone over, you should be able to identify if it's a parabola, circle, ellipse, or hyperbola just by looking at general form, and then you should also be able to use completing the square to change it into standard form so that you can actually identify the center and the radius or like different things about the actual graph.